My name is Henry, and today I'll be going through Chemistry Paper 1, Zimsec 2013. And disclaimer, as we go into this video, this shouldn't be used as primary revision. This is just me going through the paper. For anyone who's going through the paper, looking at the mark schemes and is struggling to see how to attempt the questions. So yeah, background and why I'm confident enough to make this video. In O-levels, back in 23, I got 10 A's and 1 B. The B was in technical graphics. Do not ask me why I got the B. And I just finished my A-levels. I did maths, chemistry, further maths and physics. And I really think I am the right person to be your tutor for chemistry. So if you want any chemistry, physics or maths tips, feel free to subscribe to the page. But anyway, let's waffle and let me go through the questions. So for this paper, it's going to be really hard for me to reference a periodic table. So I'm going to use my brain throughout. No periodic table. Hope I should make as many mistakes. So let's go. Which is an example of change of state? Crushing limestone into powder. This is not a change of state. Warming ice in a glass tube. That is a change of state because you're going from ice to liquid. Which gas has the fastest rate of diffusion? Fastest. Okay. Fastest. Assuming they're all at the same temperature, that means they have the same kinetic energy. So if they have the same kinetic energy, it's going to be EK is equal to half mv squared. So this means that mass is proportional to the speed squared, because the kinetic energy is constant. Half obviously is a half-wave constant. So that means the bigger it is, the slower it goes. Basically, that's it. How do you see which one is bigger, which one is smaller? You have to use the molecular mass. So how do you do it? NH3 is, ammonia is NH3. It has 1 nitrogen and 3 nitrogens. So the MR is equal to, N is equal to 14 plus 3, 17. Carbon dioxide is CO2. C is 12. O2 is 32. So 12 plus 32 is equal to 44. Nitrogen is NO2. N is 14. O is 32. So that's 46. And then methane, CH4 is 12 plus 4, that's 16. So D is the answer because this is the least heaviest. Question 3. Purity of a substance determined by comparing the experimental and theoretical values of. It can be density. It can be weight, because you can easily measure the weight. It doesn't identify anything. Density is a property of a material, but when there's something inside, you can measure the density of a mixture. Then the two answers are melting point and solubility. But since this is multiple choice, there's something that is more correct and less correct. If you go back to what you've learned in class, you probably went through melting point graphs, which are something like this. And for melting point graphs, you know that for a pure substance, the melting point is always sharp and fixed. It's sharp, it's like a straight line. But if it's impure, so the melting point for pure substance is always sharp. Let's say this is the melting point, it's always sharp and fixed. But if it was impure, it's going to melt over a range of values. So it's going to be something like this, and then it goes back to a normal graph. So the answer has to be B. 45 cubic centimeters of water is mixed with 45 cubic centimeters of alcohol, and total volume is 87. What is the best explanation for this observation? Some alcohol molecules evaporate. This can be an answer, so we'll leave it there. Water molecule and alcohol react to form a gas. They do not react. Alcohol molecules fit into gaps between water molecules. Alcohol molecules, so this can be an answer. Water and alcohol react to produce salt. They do not react. So we have two answers, but only one of them can be true. So the first answer, you have to scrutinize it. Yes, alcohol does evaporate, but does it evaporate to such a degree when you pour it? So when I'm choosing my answers between these two answers, they both seem correct, but you have to argue for both answers. I feel like for consistency, this one is more correct than this one, because you have to ask yourself, when you pour, what type of evaporation is 3 cubic centimeters? Evaporation isn't that noticeable, so the answer has to be C. Question 5. Paper chromatography is used to separate dyes in ink because the dyes are different. Okay, so chromatography is separating things due to two properties. It's the solubility and the affinity or adhesion / adhesion. So this is the solubility to the mobile phase, and the adhesion or affinity to the stationary phase. Stationary phase being the paper, and then mobile phase being the solvent. That's basically it. That is basically it. So let's see. Do we have affinity and adhesion in the answers? No. Do we have solubility? Yes. So answer is 5A. The diagram shows chromatogram obtained using this. So if something is pure, there's going to be one dye. That's there. If it's impure, you're going to have multiple different dyes on the thing. So for the blue dye, it's this thing. We have one dye, so it's pure. Green, one dye, pure. Red, one dye, pure. Black, 2 dyes, impure. Which statement about graphite is incorrect? Okay, graphite has, the carbons in graphite form 3 bonds and then have a free electron. Since it forms 3 bonds, it can be tetrahedral, so cancel this out. Because tetrahedral, it forms 4 bonds. And then, does it have a hard transparent structure? No, graphite is not transparent. Cancel this out. Does it have a square planar structure? No, it does not have a square planar structure. So obvious answer has to be B by process of elimination. An ion with the charge of +2 and the same electron configuration as the chloride ion is... Okay, so how would I go about this if I'm in an exam and don't know what to do? Okay, so I say chloride ion. Chloride ion. How many electrons does chlorine have? Sorry, now I have to go to the periodic table. Eesh, I don't want to do this, but now I need the periodic table. Now I do need the periodic table. Chloride with 17. Sorry for taking too long. Okay, so chlorine has 17 electrons, but a chloride ion has one more electron to fill the outer shell. So a chloride has 18 electrons. Boom. Okay. So the thing we're looking for has 18 electrons. 18 electrons. But it has a charge of 2 plus. For you to get a charge of 2 plus, you have to take away 2 electrons. So say minus 2 electrons is equal to 18 electrons. So the original charge before we took away the electrons should be x. So now just treat this as a simple equation. So x is equal to 20 electrons, which is the same as 20 protons for no charge. Why am I doing this? I'm doing this so that you can just go to the periodic table and see the symbol. So which element has 20 protons? Go back to the periodic table. Periodic table, let's see, 20 calcium. Calcium. So calcium. And why is calcium also correct? You can also verify that calcium is correct because calcium is in group 2 and all group 2 metals form 2 plus charges. So that verifies that calcium is a correct answer. Okay, the symbol of the particle with 7 electrons, 7 protons, and 8 neutrons is. The most important thing you have to know here is 7 protons. Everything else you can leave it for now. 7 protons is a characteristic of nitrogen. So do we have multiple nitrogen isotopes or thingies? No, we have only one nitrogen thing. So cancel everything out and go to nitrogen. Because 7 protons is nitrogen. If you check your periodic table, that's the answer. So answer is D. Question 10. The table shows the mass number of M, N, O, P. Which two are isotopes? So isotopes have different mass numbers, but the same atomic number because they're still the same element. They're different isotopes of the same element, and an element is distinctive by having the same number of protons, protons being the atomic number. So which ones have the same number of protons? We have 19 and 19. So this pair must be isotopes. That means N and P. So D. The diagram shows the arrangement of electrons in a particle. The first thing you have to do, look at the protons. 7 protons. Okay, 7 protons. 7 protons is nitrogen. So we have a nitrogen ion or nitrogen something. So cancel everything that's not nitrogen, and then you start from there. So count the number of electrons. We have 7 protons and 10 electrons. That means it's a 3 minus charge. So this should be your answer. What is the empirical formula? See the question. What is the empirical formula of an organic compound shown? Let's start by defining what empirical formula. Empirical formula is the simplest whole number ratio of a compound. For example, if you have C2H8, that is not the simplest whole number ratio. That might be the molecular formula, but the simplest whole number ratio is going to be CH4, because you can divide this by 2. Same thing. To solve this, we have to start by writing the molecular formula. So we have C, we have H, and we have O. How many C's do we have? We have 4. How many H's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 8. How many O's do we have? We have 2. As you can see, you can divide this by 2 and get C2H4O. Do we have this in our answers? Yes, we do. It's B. What is the mass of oxygen in 10 grams of sodium hydroxide? Okay, I do not know how you guys solve it, but I'm going to show you my method of solving it. So ideally what we want to do is use the fact that we know this and we know this. So we have 10 grams of NaO, and we're looking for the mass of oxygen. So what do we do? Calculate the number of moles of NaO in the thing. So number of moles sodium hydroxide is equal to 10 over 23 plus 16 plus 7, and that is equal to 0.25. Is it equal to 0.25? Let's see. There's my calculator. Something's telling me that maybe I might be wrong. Let's go. 10 over 23 plus 16 plus 1. Oh yeah, it's 0.25. Right. This is the number of moles of NaO. That's in 10 grams of sodium hydroxide. But if you look at the equation NaO, you can see that for 1 mole of sodium hydroxide, we form 1 mole of O. Or you can say we form half a mole of O2. But for simplicity reasons, I'm not going to say O2. It might be confusing for people. Just say 1 mole of O. So 1 mole of O, to find the mass, we use the formula N is equal to mass over MR. So therefore, if you want the mass, mass is equal to N times MR. That's going to be 0.25 times 16. Why we're using 16 instead of 32 is because I said O. I didn't say O2. If I'd said O2, you'd have used 32, but I said O, so we have to use 16. And then once you multiply this, you get your answer as 4. So for his answer. It's quite simple, really. A certain quantity of Al2CO this decomposes to produce 1.3 moles of Al2. The number of moles of carbon represented in the compound where. Okay, how do you do this? So I'm going to be a bit cheeky. I'm not going to write the full decomposition because that's going to be a bit tricky. I'm going to be cheeky. So what I'm going to do is say Al2CO, CO3 decomposes with heat to form 2 moles of Al. I'm just going to write this part because you see, for this, 1 mole of this forms 2 moles of aluminum. So since we know that the 2 moles have the 2 moles produced are equal to 1.32 moles, we produce 1.32 moles, but the stoichiometric ratio is 2 moles. So that means we form 1.32 divided by 2. We're trying to look for this, the number of moles that be decomposed to form 1.32 moles. That's going to be equal to 0.66. So we have 0.66. We have 0.66 moles of Al2CO3. Okay, 0.66 this. So in that 1 mole of this compound, we have 2 moles of Al and 3 moles of CO3. But we're asking for carbon, so we don't care about this part because we're asking for carbon. In that 1 mole, there's also 1 mole of carbon, so we can roughly say that it's 3. So since we said 1 mole is equal to 0.66, what about 3? It's basically 3 times 0.66. Punch it in the calculator, you get 1.98. That's how you do those questions. So if you see numerous questions that are asking you on mass thing, always go straight via through the number of moles. Simple. Go via the number of moles. You always are close to the answer if you do moles. Question 15. A chemical formula of a compound shows the oxidation number of this, blah, 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 blah. Let's see. Chemical formula is not always the same as empirical formula, so cancel this out. Can it show the relative molecular masses? No, it cannot show that. Cancel that out again. Does it show the oxidation? No, it doesn't show the oxidation, so we can cancel that out. So the only answer remaining is B. What is the empirical formula of a compound containing 64% nitrogen, 36 this? So it's basically 64 and 36 divided by 14 divided by 16. Let's get this. 64 divided by 14. 5, 7, and then 6 divided by 16 is equal to 2.25 divided by 2.25 over 2.25. So this becomes 1, and then 4.57 divided by ounce. This gives me 2. So we have 2 N2O1. And this is the only correct answer because of the T. Which is the correct formula for ammonium sulfate? So let's start by ammonium. What is the formula for ammonium? It's NH4 plus, what's the formula for sulfate? SO4 2 minus. And then you use the cross rule, meaning you have to bring this 2 there, bring this 1 over there. That means you have NH4 2SO4. Look at this, answer C. A child spilled this blah 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 onto blah 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 by mistake. What solution must it neutralize? Okay, whenever you have a neutralization reaction, always look for the number of moles and make the number of moles equal. And always can change this into this meters cubed, because this meters cubed are the SI units. So that's going to be 0.5 times 10. If you cannot change centimeters cubed to decimeters cubed and you're doing your A-levels very soon, you're going to fail. So learn how to convert from centimeters cubed to decimeters cubed. If you don't know how to do that, you just divide by 1,000. So you multiply this by this, you get 5 moles. So our answer has to be equal to 5 moles. So if you multiply 0.5 by 1, you do not get 5 moles. So this is wrong. If you multiply 0.5 by 5, you get 2.5, which is not 5. So this is wrong also. If you multiply 0.2 by 5, you get like 1. So this is wrong again. And this is the only remaining answer. And to check that that's correct, if you multiply 1 by 5, you do get 5. So 18 is A. What is the oxidation number of nitrogen in NO3 minus? A super simple question to do. Since they asked you the oxidation of nitrogen, this means that you always have to use the standard oxidation of oxygen, which is always 2 minus. And we know that the charge of this compound or ion is minus. So that means N, the charge of nitrogen should be N plus 2 minus times 3 is equal to minus 1. So charge of N is equal to minus 6 minus 1. So N is equal to 6 minus 1, N is equal to 5. 5 being a positive one because there's no sign, it has to be positive 5. So this is our answer, 19C. In the circuit shown, the ammeter showed no current flowing. So what could be the explanation to this observation? Okay, so we all know electrolysis. For electrolysis to happen, we need an electrolyte. that is ionic or molten. Why should it be ionic or molten? So that they can be charged at flows. In terms of the electrodes, they can be different materials. They can be different materials. As long as they are inert, they can be different materials, or they can be another material, but they can be different or the same. Examples when they're the same, it's carbon and platinum. If it's carbon and platinum, you can basically be the same. So looking at these conditions, or these answers to be exact, what will be the best explanation for this observation? A, electrodes Y and Z are made of two of the same element. Yeah, they can be made of the same element, but the question is asking why there's no current flowing. So this can't be your answer. They can be made of different elements, but that doesn't explain why there's no current flowing. Okay, does not have any free ions. This is true. If you don't have any free ions, what's going to carry charge? And if you cannot carry charge, there's no electrolysis or carrying. So C is the correct answer. In an experiment, 5 cubic centimeters of this were gradually added to 10 cubic centimeters of HCl. Okay, so again, start with the number of moles. How many moles in this? It's going to be 0.005 moles of now. And then moles of HCl is going to be equal to 0.01. So what they're saying is you titrate sodium hydroxide, which is a base, into HCl. But as you can see, the number of the moles of NaOH is vastly smaller than the moles of HCl, meaning no neutralization can occur in this reaction. There's no neutralization that can occur. But since HCl is acidic, the solution is acidic, but the number of moles of now are less than OL. We never reach neutralization, which cancels out P. We never get to basic. Why? Since it's acidic, the solution is acidic. We have to first pass the endpoint, which is neutralization, and then after neutralization, it can be basic. But since we never reach this point of neutralization, therefore it cannot be basic. So now we have two answers: more acidic or less acidic. Since we're adding a base, there's no way it can become more acidic. That means by process of elimination, cancel this out, and we're left with less acidic as our final solution. Apparatus shows the electrolysis of concentrated nickel chloride. What's the reaction that occurs at X? Okay, so first look at this thing. The positive end of the cell is always the positive, and the negative, the smaller one, is always the negative. So if this is positive, this one is also positive, and this one is also negative. So we're being asked what happens at X. So if this is positive, that means electrons come here. Then if this is negative, that means electrons come out this side. Okay, looking at our answers, it has something to do with oxidation and reduction. So go back to the mnemonic oil rig. Basically, oxidation is the loss of electrons. Reduction is the gain of electrons. So at X, electrons go into the electrode, meaning we lose electrons. So our mnemonic has to be oxidation. So cancel out everything that's not oxidation. Now we have to debate. Okay, can nickel ions lose electrons? Yes, they cannot. They cannot lose electrons because nickel is a metal, so it forms positive ions. Can chloride ions lose electrons? Yes, they can, because they form negative ions which can lose electrons. So our answer has to be A. The conversion of starch to simple sugar is an example of hydrolysis. I should not be explaining this. This is simple. It's a simple answer. Which method can be used to obtain the elements P and Q from ionic compound P? The buzzword is ionic. You can only separate ionic compounds by electrolysis, or by what displacement? But displacement isn't in our answers, so electrolysis is the correct answer. Mesh reaction is hydrogen acting as an oxidizing agent. Again, go back to oil rig. Oxidation is loss of electrons, reduction is gain. But we're asking for an oxidizing agent. An oxidizing agent is reduced, so we can forget about this right now. Reduction is a gain in electrons. When you gain electrons, the oxidation number decreases. So we want to see a combination where the oxidation number decreases. Here the oxidation number is 0, and here the oxidation number is +1. Here the oxidation number is +1, here it's 0. Ooh, here it's a bit confusing, so I don't think this is going to happen. It's a bit confusing. I'm not going to have this. And then if you look at this one, this is, if you do, I don't think this one's going to be a solution. This one can't be a solution. It's one of those things where you can see it when you do the question that this can't be a solution, because this is a covalent bond. So you can see covalent bonding can't be the solution. There's no change in oxidation. Okay, so let's go. Two solutions that are most likely correct are here. Elimination. In which equation does the oxidation number decrease? From 0 to 1, that's an increase. From 1 to 0, that's -1, so it's a decrease. So the answer is B. 26. The reaction between magnesium oxide and nitric acid is an example of. This is an acid, and this is a basic oxide. So base, acid, acid-base reaction, so it's a neutralization reaction. Which ion forms a green precipitate with ammonium solution? I feel like if you're preparing for your A-levels, you should know, sorry, your O-levels, you should know all the characteristic colors of every transition metal that is on the spec. For example, copper 2 plus, blue. This, green. And then rusty brown, whatever color you want. And this is always colorless, or forms a white PBT. You should know this, the ions, you should know the characteristic properties and colors. Even if you do A-level, you're going to have to know the colors. And from this, the green is Fe2 plus. If you want a chart with all the characteristic colors that you need to know for your O-level exams, comment colors. I will send you a link to my Discord where it has free charts for you to do and cram for your O-levels. So 28, Y reacts with water producing an acidic solution which gives a white precipitate with this. So first of all, acidic, and reacts with aqueous silver nitrate to form a white PBT. Already, I can tell you the answer is chlorine, because it has to be a halide ion, and if it's a halide ion and forms a white PBT, if you've done a lot of chemistry, you do know this one, white PBT, is chlorine. The other thing that shows that it's chlorine is chlorine forms an acidic solution. That we all know that. So it has been group 7. Chlorine is in group 7, answer C. 29, which metal has the least tendency to form a positive ion? Least tendency to form positive ion. So the more reactive something is, the more it wants to form positive ions. So I have to look for the least reactive thing, and the least reactive in the list is lead. The experiment shown was set up to compare the effect of sacrificial protection by different metals. So what is sacrificial protection? Sacrificial protection is basically when you have a more reactive metal attached to a less reactive metal, and usually the less reactive metal is useful and you don't want it to rust. Think of rusting. So you see ships that go in the ocean are made of iron. So to avoid rusting, they put a bit of magnesium or some, not magnesium, they put a very reactive metal on the ship hull. So instead of the water reacting with the steel, it reacts with the more reactive thing, so that the less reactive metal is safe and doesn't react. So in this combination, we have to look for which one is more reactive compared to the other one. Which one is more reactive to iron, because we don't want iron to rust. Okay, starting from here, iron is more reactive than zinc, so this cannot be this combination. Iron is not more reactive than this, so we can let that slide. But iron is more reactive than copper, so cancel this out. Ooh, my bad. Sorry, I didn't see the question correctly. Go back and see the question correctly. It's asking for which one will iron rust. Okay, so for iron to rust, it has to be more reactive than the thing. Iron will not rust in Q, because iron is less reactive than Mg, so it will not rust here, so cancel this one out. Iron is more reactive than P, so it will rust here. Iron should be more reactive. It's less reactive than zinc, that means. So this is out. So the answer is P. I'm really sorry, I made a mistake at the start. That answer is P. When crystals of copper sulfate are gently heated and color changes from blue to white, that is because, okay, this is because you are removing water from the complex. Hydrated copper sulfate is blue, but copper sulfate crystals are white. So that means when you heat it, you remove the water, and it goes from hydrated copper 2 sulfate to just copper 2 sulfate. So that means we lose water because you're heating it. So say, ooh, the contact process. Let's go. Which one is used in the industrial conversion of SO3 to H2SO4? Okay, so we're looking at this part. Is it water only? No, it can't be water only, because when you pour water into SO3, it's a very vigorous and dangerous reaction. So you can't do this one. Sulfuric acid only. It's too blank. Not sulfuric acid only. Water followed by concentrated sulfuric acid. No. The reason why we want to use concentrated sulfuric acid is we pour our SO3 into concentrated sulfuric acid to avoid the reaction being vigorous and producing a lot of steam. So putting water then this defeats the purpose. So this cannot be the answer. Wins. This cannot be the answer. Yeah, D is the only reasonable sense, because during the process, in the contact process, you have to pour your SO3 into concentrated HCl so that the reaction isn't vigorous, and then you dilute this by adding water. Then you get your controlled amount of H2SO4. So it's D. You have to know the contact process, because contact process might pop up in paper 2, so you do know the contact process. What process is used to extract silicon from silica? Straight off the bat, I am tempted to say electrolysis, but it can't be electrolysis because silicon is not an ionic compound. So it can't be this. Sorry, silica is not ionic, so it can't be electrolysis. And do remember, silica is sand. So can you pour water into sand and separate it? No, so it can be hydrolysis. So we're left with two answers. Precipitation. It can't be precipitation. It can't be precipitation. Precipitation is water. It's like rain and stuff like that. That is precipitation. So the only valid answer is reduction. Reduction is basically looking for something that's more reactive than silica. Base it in there and then let it react. Silica will come out of solution, and that's basically what's going to happen. So the answer has to be C. What is the chemical formula of limestone? The chemical formula of limestone is calcium carbonate. These are the few things that you have to know. Like, you have to know what they are. You have to know, either use elimination or you have to know them. During fermentation of glucose and ethanol, air should not enter the fermenting mixture because, okay, ethanol will evaporate. I don't think that's a valid answer, so cancel it out. Ethanoic acid will be formed. Yes, that is true. This is true. This is very true. Zymase enzymes will be denatured. If you do biology, you do know that you can only denature enzymes by rising the temperature very hot or being in very acidic conditions. So this is not true-ish. Glucose will be oxidized to carbon dioxide and water. This is also very true. Now we have a dilemma. Which one is the correct answer? Ethanoic acid will be formed. Glucose will be oxidized. Let's see. Okay. Ethanoic acid can be formed, but forming ethanoic acid has to be in a prolonged amount of oxygen. Because to form ethanoic acid from ethanol, it's two stages. You first have to form something that's a carbonyl, which is this CO, which can be an aldehyde or ketone. If you're doing O-levels, you're not expected to know this, but I'm just saying for you to know. And then you then form carboxylic acid. So not everything will turn fully into carboxylic acid at the time and become ethanoic acid. But at the same time, glucose definitely gets oxidized to carbon dioxide and water. This is very true. This is very true. And this is very true. So if I were you, I would choose D. Why should you choose D? You see, this question, they do not expect you to know that you should cancel that out because it forms as a two-step process. You first form a carbonyl group, then you form a carboxylic acid when you start with an alcohol, when you're oxidizing it. And not everything gets oxidized to the extent that turns into carboxylic ethanoic acid or carboxylic acid. And I've been tutoring kids who are doing Cambridge, GCSEs and IGCSEs and O-levels, and this answer is the most recurring. So I will safely choose glucose will be oxidized to form carbon dioxide and water. This is tempting. I know B is tempting. It's correct. But a multiple choice, you always have to choose the most correct answer. And the most correct answer in 35D is 35D. Okay, so anyone know why 35D is absolutely the correct answer for O-level? Say it in the comments. But from my experience tutoring people and revising on my own, I have seen D pop up in different examples. So D is an answer you should be confident about. Although B is correct, D is the most correct, if you understand what I'm saying. 36. Which reaction does not produce a gas? Which reaction does not produce a gas? Okay, so I would say A. But if you're using a green book, the answer is B, which is not correct. The actual answer is A. Why is it A? Is silver is the least reactive amongst everything. Silver is the least reactive, meaning if you add HCl to silver, it will not produce a gas. I know if you're using the green book, you're going to see the answer is B. The answer is not B. The answer is actually A. Because silver is the least reactive, it doesn't react with HCl that much. So the answer is A. Okay, 37. The diagram shows the structures of compounds S and T. Which substance can be used to distinguish between S and T? Okay, so look at the functional groups. So initially, start with alcohol group. Okay, so we have OH here and OH here. Since we have the same functional groups in different compounds, we cannot distinguish using these functional groups. So we cannot test for an alcohol. But if you look, we have a double bond here and single bond here, meaning we can test for single bond and double bond. What do you use to test for double bond? It's bromine water. So for an alkene, if the alkene is present, it decolorizes bromine water. So looking at answers, B is the answer. Ethane reacts with steam to form alcohol. Ethane reacts with steam to form an alcohol, which is ethanol. Look at the answers. C is the answer. 39. The equation represents complete combustion of C3H7OH. Okay, so most of you are going to go through this by working. I'm not going to work. I'm going to eliminate. It's complete combustion. So what's the difference between complete and incomplete? So in complete combustion, CO2 and water are the byproducts. CO2 and water are the byproducts. But in incomplete, the products can be different. It can be carbon plus CO2 plus this, or it can be CO plus carbon, or it can be carbon. You get the gist. In complete, these are the only two products. So let's eliminate. We don't have CO2 or H2O as a product, so eliminate A. Okay, so we have CO2, but hydrogen. Hydrogen cannot be a product, so eliminate B. C. We have CO and H2O, but we need CO2 and H2O, so eliminate C. And then D is the only remaining answer. And if you look at the answer, we have CO2 and H2O. That means D can be our solution. Coming up to the last part, polyethylene can form carbon dioxide and water by process of. Okay, polyethylene is an addition polymer. Polyethylene starts as CH, H, and then forms a long chain of CH. This. And one thing about addition polymers, you cannot hydrolyze addition polymers. You cannot break them down. Once you make the addition polymer, just like plastic, you can break it down. So how can you form these two? And if you remember something I said a while ago, like 2 questions ago, if something is complete combustion, you form CO2 and H2O. Do you think what I'm thinking? Because you cannot ferment plastic. Can you reduce plastic? No, you cannot reduce plastic. Can you condense plastic? I don't think you can condense plastic. But if you look at question 39, there's something here that I just said. Complete combustion forms CO2 and H2O. And then the question, or forming carbon dioxide and water. So that means 40 has to be B. Because think of plastic. You can burn plastic. Yes, you can. You can burn plastic, which is combustion. So our answer has to be 40. So this is basically Zimsec 2013 paper 1. If you like videos like this and you want more past paper walkthroughs, please subscribe and suggest which paper I should go through. I'm going to try and go through all the Zimsec O-level and A-level papers for chemistry, physics, and maths. I'll try biology, but I didn't do biology at A-level, so I might have forgotten a lot of things. But yeah, feel free to ask me or suggest which paper I should do, even if it's Cambridge, even if it's CIE, AQA, EdXL, any exam board, or even metric. Just tell me the paper and I'll do it for you. And any feedback is accepted. If you think I should do more to explain, I'll accept it. But anyways, please do subscribe. I'm trying to raise money for flight school here. So yeah, thank you.